Welcome to OS Project Simulator. So in this project, we will see 4 algorithms which are a part of the operating system. So first, let's try to run shortest remaining time next algorithm. So SRTN is a process scheduling algorithm. It is preemptive in nature. Now let's try to add some processes in this simulator. So as you can see, I have already added 4 processes here: P1, P2, P3, P4 with their arrival time and burst time as the input. Now let's try to run this. So after running, we can see that we have a table which shows the following terms: completion time, turnaround time, waiting time, and response time. So completion time is the time which the process takes to complete itself. Turnaround time is time taken by the process. It enters ready queue for the process till it executes. Waiting time refers to the total time the process spends in the ready queue till the CPU gets it. And response time is the time which the CPU takes to get the process first minus the arrival time. So we have the table here which shows us the data of each process and the Gantt chart. As you can see that we have P1, P4, P2 and P3. Now let's run producer consumer bounded buffer problem. So producer consumer problem is basically the problem of two process synchronization. Here we are performing it with the help of monitors. As we can see, we have a bounded buffer here. So I have entered the buffer size 4. Now let's try to fill the buffer by producing items. So as we can see here that the buffer is full, and you would have noticed that it was taking some time to produce the item and put it in the buffer, and we have put that time in the backend as some 2 to 3 seconds. Now if we again try to produce an item, it will say can't produce because the buffer is full, and simultaneously we can also consume the item, which will remove it from the buffer. Now let's try to consume the item when the buffer is empty. So here we can see that we have a prompt which is saying can't consume, buffer is empty. So we can see that the two processes of producing and consuming are occurring quite synchronized fashion. So this part is managed by the monitors in the backend. So a monitor encapsulates the shared data between producer and consumer to prevent race around conditions and to produce and consume item in a smooth manner. Next we have shortest seek time first. It is a disk scheduling algorithm. Shortest seek time first algorithm selects the disk IO request, which requires the least disk arm movement from its current position regardless of the direction. It reduces the total seek time as compared to FCFS. So let's start by entering the head pointer. So a head pointer is basically the origin or the start from where the disk arm will seek the shortest distances. So I have entered it 35 here, and I have entered the various disk requests here: 246, 57, 77, 88, 99. So now let's try to run it. So once we run, we can see the output. We have a graph here, and here we have the sequence of implementation: 35, 46, 57, 77, 88, 99, 2, and the number of cylinders. So what are the number of cylinders? Well, they are the sum of the number of disk locations that disk arm can seek to. This algo actually works by selecting the requested disk that is closest to the current position of the disk arm. So as we can see from 35, the next closest disk is 46. So it has pointed to 46, 35, 46, and similarly it points to the next disks thereafter. Here we have the graph 35, 46. So next we have optimal page replacement algorithm. The idea of page replacement algorithms is to reduce the number of page default. Specifically in optimal page replacement algorithm, OS replaces page that won't be used for the longest period of time in the future. So now let's try to run this. Okay, so let's look at a different example where we have multiple page requests and they are repeating also. So here we have taken the frame size as 3 itself, and here I have entered this series of page requests. So now let's try to run this. So if we run this, we can see that we have got 11 number of hits, and this is the order in which the frames are filling. So in the initial stages, the frames get filled in the order in which the page are requested. But then if the frames are full, then we check the page request which is farthest from the current page request, and we remove the farthest page request from the frames and insert the new page request in the frames. So this process continues till we reach the end of the page request queue, and we keep the hit counter incrementing whenever we see a page request that has been repeated. Okay, so that brings us to the end of this presentation. My team consists of Vrutansh. He also contributed in the front end part along with me. Krish handled the back end along with Saad, and Harsh and Saad together designed the code for the various algorithms. So now special thanks to Dr. Rutvik Jhaveri, our mentor, for giving us this opportunity to showcase our development skills and apply the theoretical concepts which we have learned. Thank you.